Okay. Okay, well, so let's come to our discussion about our 5-star arbitrage transaction for this semester, which is the put-call parity relationships application. What is the put-call parity? Actually, it is an equality formula that the left side of the equality is a P sub E plus S. What is the P sub E? P sub E is the market price of a European put at the beginning. And what does that mean of European put? When we talk about the option, we sometimes have one type of category which is called the European option. European option and the Americans option. Okay, the reason for using the keywords European and American here does not have any relation with the geographical areas difference. European option just simply means that this option is only being able to exercise at the expiration date of the option. Okay, however, American options are more flexible, which are able to be exercised before any time of the expiration date. Right? That is the difference. And the put-call parity here that we are going to discuss are limited to the option are limited to the European types of option. That means they are only being able to exercise at the expiration date. Okay? Like the PE. And the C sub E is the market price of European coal at the beginning. Okay? And S is the spot price of foreign currency. Okay, foreign currency here. Now the underlying is that we are going to discuss is foreign currency, such like a British pound or European euro or Japanese yen. And the S here denoted as the spot price of foreign currency at the beginning. And the capital E denotes the exercise price of European put and the call. So the European put and the European call here we describe have an identical exercise price. And R denoted as the risk-release interest rate of our home currency. Let's say it's US dollar at the beginning. And capital T is the time to expiration of European put and call. Okay? Which can be 1 year or 2 years, whatever. And our put-call parity is this equality relationship. Every time you see a mathematical formula, okay, that is the equality formula between the left side and the right side of the formula, that their relations are very, very strict. Okay, very strict. 通常来讲，我们一个数学公式，假如说是左右两边等号成立的话，那是一个非常严格的叙述，非常严格的公式 ，right? Very strict. You're probably curious to ask me instantly, "Hi, Professor, how come if we plug in all the number of the parameter of here, does not meet the equality relationship, how will you have? My instant answer for you is that perfect. That means if the equality does not hold, when you plug in all the market price of this parameter, that means there exists profitable arbitrage opportunity on the market, which you are able to take the correct arbitrage transaction step to derive the risk-free profit. Right? And I'll show you the detail step by step. Hold on a sec. So let's check out about. Okay, let's check about the proof. Okay, guys, let me tell you the proof process will be our coaching on our final examination, right? When we are going to have final examination, I think that Ajahn should be the January. January? No. December 29, right? December 29 is our final examination, right? Yeah. Because the January 5, then everybody goes home and we are going to have Google Meet. Yeah. So-called flexible learning process. And the proof process will be our final examination question. So we are going to prove why the equality relationships does hold here between the left side and the right side. So let's check about how to do the proof. Okay, our proof process will rely on construct. We construct two portfolio. Okay, to portfolio A, to portfolio B, and portfolio A will include two types of transactions. Number one, buying a put. Okay, number two, buy the underlying asset, which is foreign currency. And portfolio B will be constructed by buying a coal and buying a treasury bill, TBO. And this treasury bill have a face value of the exercise, capital E. But you probably will wonder, like it's very difficult for you to buy a treasury bill with the face value exactly the same as the exercise price of option. Because here, like Taiwan, that our face value of treasury bill is $100,000 NT dollar, which is a fixed amount. In the United States, the face value of the treasury bill is always be the $1,000, right? Okay, $1,000, so it's pretty difficult for you. Actually, you can buy a treasury bill with the face value capital E, exercise price. So what does that mean of buying a treasury bill in reality? In reality, that's what I emphasize here. In practice, we may consider this buying transaction. Okay, this buying transaction as what? As a deposit of this amount, exercise price times by 1 plus R powered by minus D. Okay, everybody know the factor. This factor is our discounted factor. when we study our financial management course in our sophomore year, right? In our last semester discussion. And if you deposit this amount, capital E, times by 1 plus R powered by minus T amount of cash at the bank, at the expiration, you may collect the face value capital E back by cash. Okay? So now we know the real concept of buying a treasury bill, TBO here, for constructing the portfolio B. And now let's check it much clearer. The initial construction cost of the buying a portfolio A and a portfolio B. To construct a portfolio A, you buy a put, so therefore you have to pay the P sub E, which is the premium of the production. Okay, so that's one part. That's one part of the portfolio A's construction cost. And the second cost that you will incur for constructing a portfolio B is the capital X, right? Why is it capital X? Capital X, as we explained just now, that is spot price foreign currency at the beginning. Right? What about the construction cost of portfolio B? You buy the coal. Okay, first step you buy the coal, so you have to pay C sub E, which is the coal premium of the coal option. When you buy the TPO, that means that you pay capital E times by 1 plus R powered by minus T cash right now. Okay, and then you will collect the face value amount, which is exactly the exercise price at the expiration back. Okay. Well, so P sub E plus S is our construction cost for the portfolio A at the beginning. And C sub E plus capital E times by 1 plus R powered by minus T is our construction cost of portfolio B. So so far, all we see are the construction costs. And now we are going to check about the payoff at the expiration. Okay, the payoff at the expiration 到期日的时候的整个损益报酬，好不好？损益报酬。Here we come to tell you a new parameter as sub capital T. What is the capital S sub capital T? We denote it as the spot price of foreign currency and its valuation. And the spot price of foreign currency, the expiration is the S sub T. Okay, S sub T. And we will check over the payoff at expiration. We have to check by two possibilities. Possibility one is the S sub T. T smaller, okay, smaller than exercise price. And the second possibility is that the S sub T is larger than the exercise price, right? So these two types of situation will bring different payoff situation. So let's check about their payoff for each portfolio. Okay, let's see. Portfolio A. Portfolio A has a component. Buying a put. Buying a put. Okay, buying a put at the situation of the S sub T is lower than exercise price. Okay, sub T is lower than exercise price. Then this put option. This put option will have intrinsic value. Okay, will has intrinsic value capital E minus by ST T at the expiration. 所以我们刚刚讲了台积电的股价，譬如说跌到，因为到期的时候跌到1000，啊，跌到1000，那你那个执行价假如是1500啊，那你现在这个卖权哦，卖权它有内在价值哦，多少？1500减掉1000，啊，可以用比较高的1500的价格把这个台积电卖掉，可以赚钱哦，赚500。 And then the second part of the portfolio A, buying a foreign currency. Okay, and now the variation. If you sell your foreign currency, you will have a sub T's cash back. The cash back, right? And let's check up. Okay, let's check about if the situation and valuation is S sub T greater than, larger than capital E. And this possibility that your first component buying the put will worth nothing, 0. And your second component buying a foreign currency will worth you S sub T. And we'll sign it up by their payoff. For the first situation, ST smaller than capital E. But portfolio A's payoff is capital E. And if the expiration scenario shows S sub T greater than capital E, then your portfolio A will end up with the S sub T payoff at expiration. What about the portfolio B? We check about the portfolio B, and you buy the call for your first component. We check about the first situation at the expiration, that is S sub T, lower than capital E. And now your call option will worth nothing. Okay? And however, if the ST is larger than capital E at the expiration, then your call option will worth S sub T minus capital E. Okay? And your second component of portfolio B involves buying a treasury bill. And at the expiration, your treasury bill will bring you the face value, which is capital E. And that is the same capital E over here. So we sum them up. Here, 0 plus capital E equals to capital E. And here, we sum it up equals to S sub T. Meaning, did you find any particular interesting situation for the payoff result at the expiration? You'll see. Okay? No matter how low or how high of the foreign currency spot price at expiration. The two portfolio will end up with the identical payoff. See? Portfolio A end up with the payoff capital E. Portfolio B end up with the payoff capital E. Identical, right? And if the spot price of foreign currency at the expiration is high and high and high, larger than the exercise price, the payoff portfolio A, you end up with the payoff as sub P. Okay, so does portfolio B. You will also end up with the payoff as sub T over here, identical. Once again, right? So capital E and capital E as sub T, identical. No matter how low or how high the spot price of foreign currency will be. Two portfolio has the same payoff at expiration. So now we are able to make a conclusion that their initial construction cost at the beginning should be identical to and their initial portfolio construction cost for portfolio A is P sub E plus S. And the initial construction cost for portfolio B, C sub E plus capital E times by 1 plus R power by minus T. They should be identical to, because their payoff and expiration are identical. So their initial construction cost should be identical to. Okay. If they are not identical, let's say if P sub E plus S smaller than C sub E plus capital E times by 1 plus R powered by minus T. If the initial construction cost of portfolio A is lower than the construction cost of portfolio B, then what will happen? There will be a bunch of investors come to buy low and sell high, right? Buy low and sell high. Okay, buy low and sell high, you will make a profit at the beginning. And at the expiration, now your payoff will be, because you buy and you sell it, so your payoff will be capital E right here, and the payoff over here will be minus E. So E minus E will sum up as a 0, right? And here the same, ST and minus T, ST sum up with 0. So you buy low and sell high, you will divide the profit instantly at the beginning. And you will end up with no win and no lose at the expiration. 0 means no win and no lose. So your final result is you win or you lose or nothing. Your final result is that you win. Why? Because as I say, you buy low and sell high, you make the money at the beginning instant. That means that your arbitrage transaction is successful. OK， 所以我们刚刚这个证明的过程就告诉我们说，我们建构这两个投资组合啊，我们去 check 它到期的时候的损益报酬都会一样。所以我们反推过来，他们一开始建构这两个投资组合的成本也一定要一样，也一定要一样。那一样就是什么？一样这一边 portfolio A 就是 P1 加 S 嘛，portfolio B 就 C1 加上1乘上1加的负 T 次方嘛，是吧？那这两个一样，这两边都一样，这两边都一样，不就是这个公式吗？有没有？一零，不就是这个公式成立吗？得证吗？对不对？就证明成功啦。那一定会反问说，那要是不一样呢？那我刚刚讲了，要是不一样，一开始的建构成本不一样。假设一开始投资组合的建构成本建构成 P1 加 S 比较低，比较少，然后 B 比较高的话，那聪明像一鸣的一定会怎么样？一定会进来买低卖高嘛，是吧？买低卖高什么意思？买低卖高就是你继续建构成 portfolio A 啊，同时间呢你就卖出 portfolio B 啊，好不好？你买它，因为它比较低啊，卖它比较高啊，所以你一开始就赚到啦。那到期日的时候呢，你的损益呢这边是变1，这边就变负1啊，这边是 ST 你就变负 ST 啊，那刚好消掉都是0。所以代表怎么样？一开始就赚到，然后到期的时候又不亏。一年，那你到底有没有赚到？有啊，一开始就赚到了，多好，好不好？我们先前那个利用 IRP 利率评价理论来套利，利率评价理论套利都还得等什么？都还得等到期日的时候才能赚到。但是这个不是，这个买卖权评价理论，一开始你就赚到了，好不好？不用等到到期，不用等到选择权的到期日，这个厉害吧 ？So I give this formula. Okay, I give you this formula arbitrage transaction application. This is a 5-star. Okay, 5-star application. Highest class, highest rank. 5-star. Right? That's my ending remark. My ending remark, no matter how high or how low the ST will be, the payoff of the two portfolios are identical. Therefore, the initial construction cost of the two portfolios had to be identical too. Okay, otherwise, an potential opportunity will arise. Therefore, so the P sub E plus S should be equal to C sub E plus capital E times by 1 plus R powered by minus D. Okay? That is our proof process. Okay, that is our proof process. And that will be one of our final examination. Okay? Appeal. Our final. December 29, right? Okay, so now, and I will give you the second question. So just suppose, as I say, if the equality does not hold, let's say P sub E plus S smaller than C plus capital E times by 1 plus R powered by minus D. Then you will buy low and sell high, right? You will buy low and sell high, so you will buy PE. And sorry, this should be buy, alright? Everybody take a look. This should be the buy. 这个讲义打错了哦，大家改一下哦。这里是 buy， 好不好 ？buy PE and buy S and sell right side is sell C and sell treasury bill, okay? And sell treasury bill in practice, we may consider this selling treasury bill transaction as a borrowing, capital E times by 1 plus R power by minus the amount of cash from a bank, right? 好，我们这里讲说卖出这个国库券，其实你应该把它想象怎么样？想象是到银行是借这一笔现金进来就对了，好。Then as we emphasize for Yini, therefore at expiration, at the beginning, there will be positive cash inflow for Yini, right? Your positive cash inflow at the beginning, okay, that is the C plus E times by 1 plus R minus D, and then minus the P and minus X.Okay, which is larger than 0, why? 就是这个公式啊，你把它移过来就，一个就减 P 减 S， 这是很好，大于0啊，对不对 ？That is the part. Okay, so there will be a positive cash inflow at the beginning. 一开始就赚到了 ，right? And we check. Okay, and we continue. Okay, we continue to check the above.The final payoff, we end up with 0 cash flow at expiration, right? As such, if I ask the question, what will be the profit you end up at the expiration for your whole arbitrage process? How much? Not just only C sub E plus 1 plus capital E times by 1 plus R power by minus D and minus capital P and minus S. Not just only this amount. You should still have to times by 1 plus R power by minus D. This interest factor. Why? Okay, because this amount is the cash profit you derived at the beginning. Okay, let's say it's 1 million NT dollar. Are you going to put this 1 million NT dollar you make at the beginning as your profit under your pillow on your bed for 1 year to the expiration? No, you will deposit at the bank, right? And because you deposit the bank, the bank will pay you what? The bank will pay you principal plus interest for the whole year. And what's the amount? The amount should be your principal amount times by 1 plus R powered by T. Okay, powered by T. This amount is the principal and the plus your interest revenue for the time to expiration date. Okay, that is our arbitrage transaction. Okay, for using Cocoa parity. Okay, for using Cocoa parity. However, here I'm going to give you a very, very interesting application of Cocoa parity on financial engineering. The Cocoa parity is not only used for arbitrage transaction. It still can be used for the application on financial engineering. Right? I may take an example over here, very interesting. Cocoa parity okay, used over here to replication, okay, to replication of the short sale. Short sale. Okay, we think about it. We may just reorganize the Poco parity formula, okay, from this form to this form. To this form, minus x, okay, minus x equal to minus c, okay, minus capital E times by 1 plus r powered by minus c, and plus capital P. What does that mean? Every time you see the minus symbol, you may consider it as a theory, alright? You may consider it as a short sale. And every time you see the symbol plus, you may consider it as a buy low, buying, right? So this formula can show you the true story, like short selling equals to short selling of the underlying asset, okay, or underlying asset, let's say stock or foreign currency, okay, equal to the combination of selling call option and selling treasury bill and buying put option, right? So this selling transaction can be replicated by three combinations of transactions: selling call option, selling treasury bill, and buying put option, right? And Aja, you may be very curious. How come we rely on this formula to replicate short sale? If you want to sell something, you just go for selling, right? You may just go for borrowing and selling. How come you take this complicated way to use the three different financial transactions to replicate the short sale? Why? The reason is that around the whole world, okay, it's always happened, right? It's always happened. The government will set a very strict law, or even will totally ban. I mean, totally block the short selling transaction if the financial market collapse. And the best timing for you to do the short selling is the market collapse, right? But at this special timing, the government will always launch very strict law to forbid smart trader to do the short sale. So you are not able to borrow the underlying asset and the short sale on the market at this special timing. So how will you do? You may use Poco parity, okay, and to replicate the short selling by these three different transactions. In terms of Chinese, that we call it as 山不转路转. Got it? Ladies and gentlemen, we end up with our top rank 5-star option transaction explanation for today. Any question or comment? No question or comment? Call me back next week. We're going to the new topics of international portfolio investment discussion.